Every app you build comes down to one question. Where does my code actually run? You've written the program, now some real computer somewhere has to switch on and execute it. That is AWS Compute, and it is the beating heart of the whole cloud. But AWS doesn't hand you one option. It gives you a spectrum, from renting a full server you control, all the way to handing over a single function and forgetting servers even exist. Over the next few minutes, we'll walk that whole spectrum, with pictures, EC2, auto-scaling, containers, and Lambda, what each one is, how it works, and exactly when to reach for it. Here's the big map first, so nothing feels random later. There are really 3 ways to run your code on AWS. 1. EC2, you rent a whole virtual server and you're the boss of it. 2. Containers, you package your app in a neat box and AWS runs that box. And 3. Lambda, serverless, you upload just a function, and AWS runs it only when it's needed, with no server for you to manage it all. Picture a dial. On the left, maximum control and maximum responsibility. On the right, 0 servers to babysit but less low-level control. Everything today is a point on that dial. Let's start on the left with the workhorse, EC2, the Elastic Compute Cloud. In one line, it is a computer you rent by the second. You pick an operating system, you get Linux or Windows, you get an IP address, and you can log in and install anything you want, exactly like a machine sitting under your desk, except it lives in an AWS data center, and you can summon or destroy it in about a minute. This is the most flexible compute on AWS, and also the one where you carry the most responsibility. Patching, scaling, and keeping it healthy is on you. If you need full control, EC2 is home. Now, EC2 isn't one machine, it's a giant menu, and this trips up beginners instantly. Servers come in families and sizes. The family tells you the shape of the machine. T and M types are general purpose. Balanced for normal web apps. C types are compute. Optimized, lots of CPU for heavy number crunching. R types are memory optimized for big N. Memory databases, and G and P types pack graphics chips, GPS, for machine learning and video. Then within a family you pick a size, large, X large, 2X large, each step roughly doubling the CPU, the memory, and the price. The skill is just matching the machine's shape to your actual workload. So you've picked a machine, but a bare server is useless. You need an operating system, and ideally your software already installed. That's what an AMI is, an Amazon Machine Image. Think of it as a complete snapshot of a ready-to-go disk. The OS, your runtime, your code, your settings, all baked in. When you launch a new EC2 instance, you launch it from an AMI, and in seconds you have an identical, fully configured server. This is the secret to scaling. You bake one perfect golden image, then stamp out 10 or 100 identical copies from it instantly. Configure once, launch many. Now the part that saves real money, because the exact same EC2 instance can cost wildly different amounts depending on how you buy it. 3 ways. On demand, you pay full price by the second, no commitment, perfect for spiky or short-term work. Reserved or savings plans, you promise to use it for 1 or 3 years, and in return you save up to about 72%. This is for steady, always-on servers. And Spot, you rent AWS's spare capacity for up to 90% off. The catch is AWS can take it back with 2 minutes notice, so it's for interruptible jobs like batch processing. Same machine, 3 prices. Here's where the cloud beats a server under your desk. Your traffic is never flat, it's quiet at 3 a.m. and slammed at lunchtime. With physical servers you'd buy for the peak and waste money all night. AWS solves this with auto-scaling. You define a group and a rule, keep CPU around 50%. When traffic surges, auto-scaling automatically launches more instances from your AMI. When it drops, it quietly shuts the extras down. You only pay for what you're actually using minute to minute, and your app stays fast under load without anyone waking up at night. This is elasticity, the whole reason the cloud exists. But auto-scaling on its own creates a puzzle. If you suddenly have 5 identical servers, which one does a user's request go to? That's the job of the load balancer, and it pairs with auto-scaling like a hand in a glove. The load balancer sits in front of your fleet as a single front door. Every incoming request hits it first, and it spreads those requests evenly across all your healthy servers. It constantly health checks them, and the instant one goes sick, it stops sending traffic there and routes around it. Load balancer plus auto-scaling is the classic bulletproof pattern for any web app that needs to stay up and handle a crowd. Now jump all the way to the right of the dial to the idea that changed everything. Lambda, serverless compute. Here you don't rent a server at all. You just upload a single function, a small piece of code, and tell AWS. Run this whenever a certain event happens. A photo gets uploaded, a request hits an API, a file lands in S3, and AWS spins up, runs your function, and shuts it down in milliseconds. The mind-bending part, when no events come in, you run nothing and you pay absolutely nothing, down to 0. No idle servers, no patching, no scaling to configure. AWS handles all of it invisibly. Lambda sounds magical, so let's be honest about the catches, because they decide whether it fits. First, it's stateless. Each run starts fresh and remembers nothing, so anything you need to keep must go to S3 or a database. Second, there's a time limit. A single Lambda can run at most 15 minutes, so it's for quick tasks, not hour-long jobs. Third, the cold start. If a function hasn't run recently, the very first call takes a beat longer to warm up. And you pay per request and per millisecond of runtime. Lambda is brilliant for short, event-driven, bursty work, and a poor fit for something that must run constantly all day. There's a middle ground on the dial, and it's where huge amounts of the industry now live: containers. A container packages your app together with everything it needs to run, the exact libraries, the exact versions, into one portable box that runs identically on your laptop, in testing and in production. No more, it worked on my machine. AWS runs containers two main ways. ECS and EKS orchestrate them, deciding what runs where, and Fargate is the serverless option. It runs your container without you managing any servers underneath, just like Lambda but for whole long-running apps. Containers give you Lambda-style consistency with full long-running control. So, decision time, the cheat sheet you'll actually use. Reach for Lambda when your work is short, event-driven and spiky, a thumbnail maker, a webhook, a scheduled task, and you want to pay nothing when idle. Reach for EC2 when you need full control, a constantly running process or special software, and you're willing to manage the machine. Reach for containers and Fargate when you want a consistent portable app that runs long-term without babysitting servers. Quick rule of thumb, start with Lambda for small event-driven pieces, use containers for your steady services, and turn to raw EC2 only when you truly need that low-level control. Let's anchor all of it on PhotoApp. The main website, the thing that's always on, serving pages, runs on EC2 instances behind a load balancer, inside an auto-scaling group, so it grows at lunchtime and shrinks overnight. But making a thumbnail every time someone uploads a photo, that's short, bursty, event-driven, a perfect Lambda. The user uploads to S3, that upload event triggers a Lambda, it generates the thumbnail and writes it back, then vanishes, costing fractions of a cent. One app deliberately split steady work on EC2, spiky work on Lambda. That blend is exactly how real systems are built. Here's the whole compute picture in one diagram. A user hits the load balancer, the single front door. It spreads traffic across an auto-scaling group of EC2 servers, each launched from the same golden AMI, growing and shrinking with demand. When that user uploads a photo, it lands in S3, and that event fires off a Lambda function that builds the thumbnail and disappears. Notice the shape. The always-on web tier lives on EC2 behind the balancer, while the short, event-driven jobs run serverless on Lambda. Steady work on the left of the dial, bursty work on the right. That is a real production compute layout. Let's bring it all together. EC2 is a server you rent by the second, maximum control, your responsibility, and you size it by family and instance type, launch it from an AMI, and buy it cheaper with reserved or spot. Autoscaling and a load balancer turn one server into an elastic, self-healing fleet. Containers and Fargate give you portable, consistent apps without works on my machine. And Lambda lets you run a function with no server at all, paying nothing when idle. It's a dial, from full control to 0 servers, and now you know exactly where each piece sits. And that is AWS Compute, sorted. Not a wall of confusing services, just one simple dial, from EC2 where you run the whole server, to Lambda where you run only your code. Pick the point on that dial that matches the job, and you get the right mix of control, cost, and convenience. If compute finally clicks now, do me a favor and subscribe to Beyond Cloud. The whole point of this channel is taking the scary parts of AWS and making them simple, with pictures. Tell me in the comments which service you want me to break down next, and I'll see you in the next one.